All right, so we're going to start with functions. So what is a function? A function is a mapping, and mapping is just a mathematical way of saying we move one element from one place to another. So a function moves exactly one element, assigns one element of the range, namely to one element's domain. It's kind of a funny way of putting it. Basically, for every time you put in something, you get out something. But it only gives you one something, and that's important. We'll get to that. Here, the x is an independent variable, so f of x, also known as y. So sometimes we write functions. So when we write a function like this, y equals x squared plus 2x plus 1, which is a parabola, what we're really writing is y as a function of x is equal to x squared plus 2x plus 1. That's really what we're doing, okay? So it's really that. Sometimes we call what we hit the image of the function. So let's list some functions you guys see in everyday life. So you guys will have to type in a couple answers. It's not going to be all of me just lecturing. So what are some functions you guys see in your everyday life? Okay. Does anyone have a function? Wages, hours, works. Yeah, wage and hour work. So let's just say your paycheck is equal to a function of your hourly wage times the hours you work, right? So if you get paid, I don't know, let's just say $15 an hour. So if you get 15 per hour and you worked, oops, that does not look like a multiplication, and you worked 20 hours, you can figure out what your paycheck is in dollars, right? So that works really well. Oh, someone. That's right. Any other function that you guys can think of that you just encounter in your day-to-day life? Height and age, that is a function. Okay, so yeah, so your age, so your height is a function of some sort of growth rate for you, which is unique to you. So this is your growth rate times your age. This is actually probably a really complicated function in itself, but because you know, we get up, we hit our peak height, and then eventually we start to shrink just a little bit before we cascade. That's just because you lose bone mass and your skeleton just kind of crunches down on itself. Yeah, so height and age. Another one for when we used to drive around was gas mileage, right? So amount of gas use is equal to your miles. Miles driven times your miles per gallon, right? Times your miles per gallon, right? So that would tell you how much gas you've used. Temperature is a function of time throughout the day. There's a lot of stuff. So there's a lot of functions you just incur in your life. So there's two types of diagrams that we see for this. And the one is called the machine diagram. And here, that's where we have some sort of machine, which we call our function. And so it takes in an x, it goes through the machine, and outputs some f of x. So this is my input, this is my output. And so for each x, you'll get a different f of x. We'll actually show that here in a bit. The other one's here. No, boy, my Alexa's talking to me. I'll just put you on mute. There we go. You guys ever have those crazy, Alexas or Google Homes or Siri things around your house and you're sitting there talking, just randomly talking to you? It's like, I didn't say your name. Anyway, so the other one is we have this arrow diagram. And here we'll have our domain. Oops. Domain, which is with the D. Let me make my pencil a little thinner. Thick. And then I have my range. Yeah, that's better. So I have my domain and range, and here we're going to have some x. And that's going to translate over to some f of x. Okay, and for here, most of our domains will be this, which is the reals, and most arranged will be the reals. Have you guys seen this symbol before, where this is the R with like the extra slash, meaning real numbers? Yes, no? Yes, okay. At least some people have. So 90% of what we'll be doing is this. And so let's actually write in a function real quick. So f of x equals, actually I'll put in this function here. X squared plus 2. And so here, I plug in 0. 0 goes, of course, to 2, because 0 squared plus 2. And then here, it'd be, let's put in 2. 2 squared. So 2 squared gives me 4, plus 2 would give me 6. And so this is what this is. And so here I'm mapping the reals onto the rails. Okay, so let's go through an example. All right, so here, if I'm given a function x squared plus 2, so we're going to express it in words. What we do to produce this, we're going to evaluate it for different things. We're going to find the domain range. So let's just start with words, express this in words. So I'm going to express with the words is, if I was going to tell a friend how to perform this function, I would say square your number. So whatever number you have, you will square it. Square your number, then add 2. So if I was just working with a buddy and say we're doing, I don't know, woodworking, and for some reason that's the function we needed to run through, I say take whatever your measurement is, square it, and then add 2. So it's just a way of expressing in words. To actually evaluate it, so here, this is evaluation. You just plug it in everywhere you see an X. And when you do this, please, for safety reasons, always put what you plug in your X as in parentheses. That way you perform the proper functions upon the X. So here, this is equal to, so this is 9 plus 2, so you get 11. Notice here, if I skip the parentheses, I guess I'll do it here. So if I skip the parentheses, plus 2, this is actually not 11, right? As it's written here, because you square before you negate, and therefore this would be minus 9 plus 2, which gives you minus 7. So this is incorrect. So don't do this. So always plug it in a parentheses, even if it doesn't really matter. It just it's a good practice to have, right? Sometimes you just need to learn good practices for math. So f of 0, if I plug in 0, of course I'm going to get 0 squared plus 2, which will pump out 2. And then here, f of the square root of 7. Oops, that does not look that clean. There we go. 7 equals, is equal to the square root of 7 squared plus 2, which of course is 9. All right. I didn't leave myself too much for stuff. Domain and range. We talk about domain and range a lot in 126 and 127. They kind of like harp on it a little too much. It's important to know, but I'm not going to be too particular about it. Does anyone know what the domain of this function is? Let's see if I can get a response. Yeah, all real numbers is correct. So all real numbers, because the domain is anything I'm allowed to put into this. And so when I'm allowed to put into this, well, any number is fine. So, and what is my range? What can I get out of this? That one might take a second for you to think through. Yeah, 2 to infinity is correct. Someone got it. So here would be 2 to infinity. And here we use the bracket to mean including 2, because if I plug in 0, I do get 2, but everything else, this has to be positive, and so I can't get anything below 2. And so it goes all the way to infinity, because I can get above 2, sure, certainly. All right, and then draw the machine diagram. I don't have room to draw all of them, so I'm just going to draw one. So here we'll draw, so let me do it for -3. So -3 goes into my cute little machine. And what out comes 11? Oh, I can do square root 7. Square root 7 goes into my little machine. Oh, and it outputs 9. Okay. And so this is what the machine diagram is. It's just something cute that we use. All right, so let's go ahead and just move on to the next one. All right, so let's talk about a piecewise function in a form that 90% of humankind has dealt with. So you're given a cell phone plan of $59 a month, and it comes with 500 free minutes and charges 10 cents a minute after for everything over this. So here we can define what we call a piecewise function. So the cost of my plan is $59 if I use anywhere between, for X's number of minutes I used, is anywhere between 0 to 500. And the 500 minute is free, but after that I have to pay 10 cents for every 10 cents for every minute. So anything over 500 I'm paying 10 for, okay? So C of 258 is what? If it's a simple number, yeah, 59, right? And so it's the same thing as C as 500. Yeah, C is 500 also will be 59, but C of 532 will equal, and we'll go ahead and plug it into here. I mean, here we technically plugged it in because there is nowhere to put it. So we'll have 59 plus 0.1 times, I'll just go ahead and, I guess I better practice what I preach. 532 minus 500. This simplifies, of course, just to 32. 32 times that will give me, if I can do math in my head, $62.20. Okay. So, yeah, that's correct. So, yeah, so that's what we do here. All right, so now we're going to plug in things which are not numbers, okay? So we can plug in non-number things in the functions and we can still crunch through them. This one's probably the most important. You'll see it on the homework at least 3 times, and you will see it on the first exam, and you will see it on the final exam. I can almost guarantee it will be there. The reason is this is a derivative. You don't know it yet, but it is. And so I think it's one of the more important things to get you ready for calculus if you can do this. Because you're going to do this and then take the limit as it goes to 0, as h goes to 0. So, all right, so evaluate the function for the following. So here, you think that these two produce the same function at the end of the day, the same result? Yes or no? You guys think so? I hear no. I hear 1 no, 2 no's, lots of no's. Yeah, the answer is it is not. So let's just crunch through it real quick. So here we have f of minus a is equal to 2 minus a squared plus a minus a minus a 1. And here we'll have f of a, which will equal minus the function of 2a squared plus a minus 1. Okay, so let's go ahead and evaluate this down. So this becomes 2a squared minus a minus 1. This becomes minus 2a squared minus a plus 1. Yeah, so these are indeed different. Okay. Just something to be careful and to pay attention to where the negative sign matters. Here, let's just figure out what f of a plus h is. All right, so here we'll have f of a plus h is equal to, so be 2 times a plus h squared plus a plus h minus 1. All right, so if we crunch through this, so this would be 2. Please be careful here that this is not a squared plus h squared, but it's, oops, a squared plus 2ah plus h squared. Does everyone see where that came from? Yes, no, maybe. Foil, yeah. We're foiling here, yeah. It's one of the most common mistakes I see people just throw it in, but here you actually have to do a plus h, a plus h. So just be careful. And so you get a squared, ah, so it's the 2ah plus h squared. H minus 1. So if we just finish this out, I'll get 2a squared plus 4ah plus 2h squared plus a plus h minus 1. Okay. Now we can go ahead and do d, but notice we've already done half of it, or we've done most of it. This is this one, this one's this one, so we can just plug that in. So 2a squared plus 4ah plus 2h squared plus a plus h minus 1 minus 2a squared minus a plus 1. And we're going to divide all that by h. So here I just pulled this here and this here, since we already calculated it. And then, so we can cross off the 2ah, we can get rid of the a, we can get rid of the 1, and so I'm left with 4ah plus 2h squared plus h, all divided by h. I can factor out an h, so I'm going to do that as a separate step. 4a plus 2h plus 1 all over h, and then I can safely cancel. Remember, you can cancel multiples from top and bottom. So if it's everywhere, we can't cancel terms. So I couldn't cancel this. Canceling this h with this h is incorrect. Right? If I pull it out as multiples, then I can do it. Just remember your fraction rule. So that gives you our final answer of 4a plus 2h plus 1. Okay. So that's how you do that one. You're going to be doing 2 or 3 more of these on the homework. These are important to do because the next part, if you're going to do this for a derivative, you send h to 0, and then you have your answer here is 4a plus 1. So, all right. Any questions so far? I feel since I'm kind of just guiding everybody, since it's hard to get a lot of live feedback and I stop you to do anything, I feel like I'm just trouncing through it, but it's okay. If there's no questions, I'll go ahead and go forward. All right, so let's do the last one. Hopefully you guys are following along with your little, either on paper or on a pet tablet. I mean, I will post these later. I'll figure out how I'm going to do that. It is being recorded, so I am recording right now. So just so you know, I will be posting these later. I'm trying to figure out if I might have to mess with some settings. I may have to crop the video to make sure that no one's being seen. So I'll have to figure out how to do that, but I'll get that done. So let's go ahead and do this. So let's 4 ways to represent a function. So we're going to do this. And so we're going to express the formula of converting Celsius to Fahrenheit in 4 given ways. So let me start with the easiest way. So something, if you just went on to Google and looked it up, what would you get? You'd probably get something here. So I want to convert from Celsius to Fahrenheit. So here I have a function where I plug in Celsius and I get my Fahrenheit out, okay? And so I'm going to get 1.8 times my Celsius. I'm going to add 32. So that's what the function is, more or less, because 0 degrees Celsius is 32 degrees Fahrenheit, the freezing water temperature. No, the temperature of the freeze water. Don't mind, I have dyslexia. So sometimes I may say stuff that doesn't make any sense, but my brain tends to pick it up. And sometimes I write stuff backwards. But since I've done most of these notes before, I've gotten more. There should be less of those. So that's what our function is. So my function of Fahrenheit is given Celsius. So that's what my input is, right? Verbally in words. So Fahrenheit, it's a good thing I have it spelled because I can't spell. Fahrenheit is 1.8 times Celsius. Oh, someone else in chat saying they have dyslexia. Dyslexia is, they used to call it a learning disorder. Now they don't. They call it intellectual trait, because being dyslexic has its advantages because your brain's is capable of doing abstract thinking better. For some weird reason, like Steve Jobs and a lot of other, like Einstein's, all these other people were like dyslexic. It so it's not necessarily a bad thing. It's a different thing. Just I don't know, you get used to it. So here we get Fahrenheit is 1.8 times Celsius, and then add 32. That's what it is in words. Here, if we had a table, we'll go ahead and just put in some really simple things. So we'll do 0 is 32. If I plug in 1, I'll get 3.38 because I'm just adding 1.8. If I plug in 10, which makes a little bit more sense, I'll get 50. -1, so it'll be minus 1.8 will give me 30.2. And then minus 10 will give me 32 minus 18, which will give me 14. Yes. And then here we go ahead and graph this. You'll see a lot of these cute little graphs on the homework. Go ahead and scale it to what makes sense. Here we're going to do -10 and 10. And then here I'm going to say halfway up is, let's just go ahead and let's just make this 30. Okay, so 32 would be our 0 point. At 10, I should be at 50. And then at -10, I should be at 14. That creates my line. This is a linear function. I think I can cheat with my, yeah, there we go. I can cheat and make lines. This actually extends out. And there I've done it graphically. Okay. So these are the 4 ways to represent a function. We'll be doing more tables and graphs later. You'll be working with this in the homework.